When we do a climate science presentation, we always start with the loaded dice game as folks are coming in. They jokingly ask, "What will I win?" or something like that. But what they do win is a much deeper sense that they are already experiencing a warming climate, even while daily weather may be bouncing from normal to cold. It's a roll of what turn out to be changing dice.
Rolling the dice. We're all familiar with rolling the dice, and we're comfortable that we'll have about an equal chance in turning up a number from 1 to 6 with each throw. But what if those 6 sides changed as we got older? That's an odd question for sure. What if more of the 6 sides had 5s and 6s, and fewer had 1s and 2s as we move through the decades? What if we started seeing dice like these? Take a look at those. One has many sides with 5s. The other one has 2 6s showing. The game will have surely shifted from the one we played in my youth if you have this kind of dice. This is the situation we're having with global warming. Folks of my generation have probably sensed that things are generally warmer than back then. But it can be easy to discount these thoughts because it still gets miserably cold at times. There is a way to tell, though. It's found in the changing probabilities of average temperatures over time. The loaded dice game captures the actual data over the 70 years from 1950 to 2020. Obviously, 2023 and 2024 have gone on to be setting all-time records. July 21, 2024 was the hottest day ever directly recorded on Earth, and the hottest in the last 120,000 years. But even without adjusting the game to these recent warmer conditions, the message is beyond clear. Global climates are changing, and rapidly. So let's get right into playing the game. Here's a shot from the first time we played it. The 3 dice being tossed are loaded in different ways, as you will see. In the back, the score for that roll is being recorded for each of the 3 dice. This turned out to be a lot of fun. Folks coming into the event seemed delighted to invent new ways of throwing the cubes across the room. Before we go further, I want to emphasize the game is based on actual data for the average summer temperatures in the land regions of the Northern Hemisphere, where most of the planet's human residents reside. The game was inspired by studies by James Hansen and his collaborators. Dr. Hansen will always be remembered for bringing proof of actual global warming to the world's attention in 1988 congressional hearings, and for his incredible work since. Here are the kinds of results Hansen et al. Developed. We'll get into the specifics in a minute, but for orientation, the first curve shows in a familiar bell-shaped curve the 30-year period from 1950 to 1980 and establishes a baseline of cooler, normal, hotter, and extremely hot for the other curves. The second curve documents a shift toward hotter for the decade 1990 to 2000. The third curve shows an even greater shift for the decade 2010 to 2020. It may sound crazy, but a recent look back over the last 70 years, and specifically back to the reasonably stable climate I experienced when I was a kid, the 30 years from 1950 to 1980, confirms the suspicion that things are indeed now getting warmer. let's take a more careful look at what has been happening. Weather is what's happening outside today, or last month, or this week, or even this year. That's what's going on. Climate is the average of the weather over a longer period of time, typically 30 years. As we will see shortly, in the recent past, things are changing so rapidly that it is not unreasonable to look at shorter periods, in this case, a decade's worth of weather. Here's what has become the defining documentation of global warming. It is the average global temperatures since 1850, 174 years of credible data. So, the structure of our game. The period 1950 to 1980 was the last time there was an extended period of stability in the global average temperature. The red circle denotes the average of the yearly notations of temperatures. The red circle depicts the climate of that period. The dots inside the circle document the average yearly weather, as do all the dots on the chart. Die number 1 will be constructed around this 1950 to 1980 period, which is hereby declared as our baseline and with which the other dice will be compared. Likewise, we will design dice number 2 and number 3 in the same way. It is easy to see that the global conditions, climates, have actually changed, and that the annual temperatures within those climates are in different ranges than before. So, since die number 1 is regarded as our baseline, 1/3 of summers are defined as normal and are given 1/3 of the 6 sides, or 2 sides, 1/3 of the 6 sides. Likewise, 1/3 are designated as cooler and 1/3 as hotter. An extremely small portion, 0.1%, is captured as extremely hot and dealt with as a slim dark red line on one of the faces. If that side comes up around 17 times, one of those would be credited to extremely hot. Directly from Hansen's charts, we can discern the growing proportions of hotter and extremely hot weather, and these are assigned to the sides of dice 2 and 3. You can see how that makes the sides of number 3. Look at the far right of this chart. Very different from the baseline distribution of die number 1. That thin line of dark red in die number 1 has expanded to more than a full side. Most telling, what was 33% of die number 1 for hotter and extremely hot has become 88% of die number 3. We are truly loading the dice. So to review, the die itself is the climate we want to understand. The weather of that climate is captured by the distribution of colors on the surfaces. Weather is whatever shows up in that time period when the loaded die is rolled. Each die is a different climate. Weather is what you get when you roll that die. Let's look at the results of a recent game. From die 1, the 30 years we defined as our baseline normal, to die 3. Blues, the cooler, basically disappear. Greens, the normal, are far less. Yellows and reds, which is hotter and extremely hot, come to dominate. It's almost like the dice are loaded, and that is the point. And that's the world we now live in. It is different from 1950 to 1980 and even different from 1990 to 2000.
So, what is the takeaway from this study? We could still get a cold spell at any time. There still will be a chance for that, and the dye will keep some portion of its surface in blue. But you don't get to choose just any dye. You are stuck using the one for your current climate. The actual weather will jump around, but the probability of a cool summer day is becoming more remote, while the likelihood of hotter and intensely hot days is far greater than even a few decades ago. And finally, all our thanks to Jim Hansen and his collaborators. They have done such good work. Mac will put some links to his work below. And thanks to you all. We hope this has been informative and helpful.